typical application for camera-based or non-contact measurement is the measurement of plastic parts or parts with soft material. Obviously, making contact with these parts will actually introduce some deformation of the part, so we need to measure them in a non-contact method. The most challenging parts for a lot of camera-based systems are either translucent, white or black plastic parts. These are typically the parts that most camera systems find difficult to see. Our system's particularly good at that. The Gagemaster system with its LED lighting and bespoke camera is extremely well tuned to seeing black plastic and white plastic parts. So here's an example. If I zoom in on this spark finish here and we come into focus, you can see the level of detail that we're able to see on this plastic injection molded part made from a black plastic. I'll come back down to the minimum zoom position. This is actually a recess, and you can see some of the material here which is higher is out of focus, and I want to see right into the corner of this radius, which is where we are now. Using the lighting here, I was able to see that, but other lighting conditions completely obscure that edge, so you can see that the ability to position the light exactly where we need it is key to be able to measure this particular feature. Another area of interest is the ability to control the edge detection criteria. When this form is open, I'm able to fire the tool. We're going to do that now, and I can determine the scanning direction. If I move in this way, I'm scanning from the light from the dark area into the noisy area, and if I draw the tool this way, I'm scanning from the other direction. So I'm going to scan now from the dark area into the noise, and if we look on this form, you can see that the tool is continuously firing, and I'm able to see the points that would be taken if I accept these particular edge detection parameters. If I zoom in on my digital zoom slider there, you can see the points that would be taken, and for the most part they are good. The points that are not good have been greyed out because I have some point filtration applied, which is removing flyers from the least squared best fit radius that we're calculating here. However, to ensure that each part is measured in the same way, I'm going to set some parameters on here. If I go to default, then the edge, you can see how the data points are now spread over a much wider range. We've got points way into the material which are undesirable. So if knowing that I'm scanning from here in this direction, if I tell the software that I'm actually only interested in the first edge that we see, you can see that most of the good points, the blue coloured points, are now falling on the correct edge. So I'm able to determine the edge that we're interested in. The first edge, the second edge, the third, the last, the strongest, the sharpest. There's any number of edge detection parameters that are available in order to teach the system the edge that you're interested in. So I've chosen first. I'm going to measure that now, and we get a nice clean measurement using the data that's been taken from the feature that I'm interested in. So the ability to customize your edge detection is absolutely critical when measuring parts of this nature. Again, if I go to default now and we measure this line, I'm getting points that are spread all over the place, and typically this is the sort of information that a lesser capable vision system might return, but I'm able to quickly, with one mouse button click, teach the system the points that I'm interested in. I can adjust my edge percentage, I can move those points to where I can visually confirm that they are correct, as they are now, hit the measure button, and I'm good. So customizing your edge detection is key, and what's more, when that program is replayed in a batch production environment or scenario, then each measurement that was customized is replayed in the same way. So the custom edge detection parameters that I set up are stored with that measurement in the program. So having spent some time creating the ideal lighting and edge detection setup, you can rest assured that the measurement will be, the integrity of the measurement is repeated because the conditions are replicated every time you measure that part.